So I'm going to give an introduction to the integrated business operating system with both Vector Prism and our causal control core, or what we call C-core. And what we're trying to do is basically we're going to have this intelligent business systems with many different modules, like learning management module, human resources management module, financial management module, even franchise management, communications modules, all these different business modules. And these different business modules will deliver information out to Vector Prism. So Vector Prism will vectorize that data and make that data available to the causal control core, which is the brain of the system. And here we analyze the data, we do causal inference analysis, and then we also derive control recommendations and control law that would deliver back to each of these individual Ibos modules. So with this, visualization can be helpful. Data is being delivered directly from here to here, and also vectorized data from here to here, so that we can get some kind of global comprehension between all of these business modules. And then based on the global comprehension of everything going on in these business modules, we can make decisions to optimize not only individual models, but those decisions would also optimize the entire business system through using like Granger causality, transfer entropy, and other causal inference tools. And then based on that, we use prediction in order to create recommendations, and then using feedback loops, we actually control the systems with those recommendations. They're not just analysis, they actually can be control law. So that's the concept. Let's look at this introduction here, where the Ibos modules, they actually act as operational systems, generating source data for business functions. So that's the Ibos here. They perform essential local tasks, local to each module, and basic data validation, so syntax, format, nulls, basic ranges, things like this. And then they egress that validated data via Kafka. So that's the streaming data flow. Kafka manages that, one tool to manage that. But we use schemas defined in a central registry. So what are the data schemas that are supposed to come out of each of these modules and go back in? So we need to validate those first using a schema registry. And then these receive back from the causal control core, they receive back control signals, setting adjustments, parameter updates, task triggers, using these defined protocols, using these schemas. And then the control signals actually actuate these different elements inside each operational domain. So that's the Ibos modules, what they're doing. And what Vector Prism does, then Vector Prism consumes these standardized data streams from the Ibos Kafka topics and makes sure that those are validated against the schema registry. And then Vector Prism will vectorize the relevant data, it will pool that relevant data, and it will make this pooled and enriched data available to C-core using these same Kafka topics or direct access to its storage layer. So C-core can actually access the storage layer here for non-vectorized data, but for data that it makes sense to vectorize, so we can pool it. And C-core can also pull non-vectorized data into that pool from here. Vector Prism is actually a separate platform. C-core is part of DataBlock. It's the data science toolbox, or the machine learning pipeline inside DataBlock, but it's the smart components. And so that's what Vector Prism does. And then the causal control core, that's the central brain. It ingests the pooled vectorized data from Vector Prism and also any supplementary raw streams from Ibos. And then it performs all of these centralized advanced processing and feature engineering, all the statistical analysis, all the machine learning, all the causal inference, all the simulations, because once we get these causal relationships, we want to do prediction and then simulation to adjust our predictions and to validate our predictions. And then we want to send these control actions back through the control routers and dispatch these as specific protocol or signals back into the targeted Ibos modules. Let me give you another view of this in a kind of a larger image. So let me go here. So on the far right, you have your different modules: human resource, financial management, logistics and supply chain. These are Ibos modules. Remember, this is an integrated business operating system. And I've gone ahead and said, like for example, human resources, we're going to have employee and contractors, core HR functions, performance management, benefits administration, time and attendance tracking, KPI dashboards, right? So anything for your human resources here. What's happening again is that you'll see that right here is your HR module. This is a graphical depiction of number one. And the data from The HR module is going into Vector Prism, and Vector Prism is creating this federated data pool. So here I've got my LMS module, my IoT module, my finance module, my marketing module, my documents. You see down here you have, where is it? Document Compliance Manager, that's this one. Here's your logistics module, here's your communication module. So all of these modules are contributing data into data pool, and then this data gets federated, or it gets pooled through Vector Prism. And then these big pipelines, basically this is the C core, the causal control core, where we process it, we do feature extraction. That should be an X, not an S. Statistical analysis, where some of the causal control happens, and we do our machine learning, causal inference, and then control system. And that's where we get this feedback loop, where we're sending these small control decisions back. See, this is a big pipeline where we're just considering everything here, analyzing everything. Once the analysis has been completed, we have distilled decision processes, which have to be piped back to the individual modules to make adjustments. Now, the LMS or the IoT module is not going to, within its own context, is not going to understand any of the big global picture. But because the control is coming from the global picture, that means not only are we optimizing what happens within the IoT system, but we are also optimizing this relative to what's happening in the whole system, in the whole Ibos system. So you have global awareness, basically. You're equalizing and leveling off the performance of all the modules against each other. Right here is our first index module. Welcome to the Central Documentation Hub for Causal Control Core. So this is our development project right now. And C-Core serves as a central processing and decision-making brain within our operational ecosystem. It ingests data, and it streams these data streams that are originating from various business operation systems modules and from Vector Prism component. And its primary responsibilities include 1. Centralized data governance, or applying advanced semantic and business rule validation beyond the basic checks performed locally by each Ibos module. Then advanced analytics, so it performs these complex feature engineering, the statistical analysis, the machine learning, and the causal inference, and the system simulations. And once we have that, then we generate the control signals and the recommendations based on that analysis. And then finally, we do the orchestrated actuation, where we dispatch those commands back to Ibos modules using the control router in order to affect the changes in the operational environment and, of course, to optimize the systems. The system is designed to provide deep insights into system dynamics, to predict future states, to understand causal relationships, and ultimately to optimize the operational outcomes through this closed-loop control. Now, the target audience for this documentation is for our software engineers to do the developing and maintaining of C-Core components, Ibos modules, or the integrations. Now, what I mean by integrations is that, yeah, we're building a vertically integrated system of platforms, but we did do a separation of roles because we also want to offer Vector Prism and DataBlock services to other companies. Remember, C-Core is part of DataBlock. Let me just see if I can show you that here. Here's our DataBlock platform, which is a node-based and data science platform where we have a database nodes we can drag out here. There's a gateway where anyone who has access to this gateway then can access the service module. The service can have multiple modules. You come in here and you access your database. You do your queries here. You can add parameters. You have your HTTP node. You have your GPT nodes, workflow nodes. These are workflow nodes, always on the right. So this workflow node is saying, listen, go out to this HTTP node and bring data in from some API. And then take the data and send it to the next workflow node, which says, okay, I want another HTTP node. And then bring that back in. And then this is another HTTP node. So this is I think it's our social media campaign service. So we're dealing with a lot of different APIs. But anyway, whatever the other service we want to create, we can do that in here. And we have these shared workflow nodes, so I can share with other modules here. Branch nodes, where I can do multiprocessing. So I'd have a workflow node that goes to a branch node, and then I can do parallel processing. and it will send that back to the branch node, back to the workflow node, and then send that double processed data to the next workflow. Here's the join node. Here's a traditional conditional node and a GPT conditional node. These are interesting. We have join nodes where you can bring two processes together again. You have email nodes, file nodes, parse nodes, markdown nodes, scraper nodes. And within here, we also go ahead and integrate the data processing, feature extraction, statistical analysis, machine learning nodes, causal inference nodes, control system nodes. These are all part of the C core portion of the data block solution. Right, so that's what I mean by that. Now, the key technologies, we're going to be leveraging mostly Google Cloud Platform because of their Kubernetes and Kafka support. Then schema registries, Avro and Protobuf, and then for stream processing, we'll also deal with Apache Fink together with Kafka to manage that time series data. Orchestration, obviously, Kubernetes. Storage, we'll be doing Cloud SQL and Protege. Protege is nice for real-time data. Analytical data warehouse, BigQuery. Vector embeddings, we'll be using Vertex AI and vector search. We may use other data stores for vector embeddings too. But for machine learning and analytics, basically it's Python based, all the way, PyTorch, scikit-learn. For the causal, we'll be using 2Y, EconML, and stats models for the dynamical causal analysis or neural network causal analysis. This would be for static, and I'm not going to get into that right now. Then for workflow management, we'll do MLflow. This will handle all of our models and iterations. Then for observability, Prometheus, Loci, Tempo, and Grafana, especially Grafana for PLTG stack, and then cloud monitoring, of course. We'll use logging and trace along with Google Cloud Monitoring. And then for security, we'll be dealing with HashiCorp and Vault and OPA. Then for the infrastructure tools, Terraform, GitLab. And then here is links to the different components in our documents. It's pretty extensive, so new developers are going to want to get some orientation here. The target audience here is not just our engineers, but also our data scientists and analysts, then the platform engineers, and then system architects. All right, so that's an introduction to the Causal Control Core project, which is actually part of a much bigger project. Going back one more time to take a look at this ecosystem here, where we're going to be having the integrated business operating system. And this will be working in coordination with Vector Prism and C core. And then, of course, we haven't really talked about governance and oversight, but we want the integrated dashboards and explainability layer. We talked about some of the tools we're going to be using for that. In the way of introduction to any new developers who come in, or for anyone who wants to understand what we're doing a little bit, I think this is nice to have a little bit of an introduction video for that.